Hello everyone. In this video, let's discuss about the insertion sort algorithm. If you are new to our channel, please subscribe for more engineering related topics. Now, if we consider the insertion sort, how to solve the problem? First, let's index them 0, 1, 2, 3, 4, 5. Therefore, 0 to 5 means what is the length? Length means n is equal to 6. Length of this array or the list of elements is equal to 1, 2, 3, 4, 5, 6. Okay. Now this is over. Now how to proceed with the problem? The first step is sort the given list of elements or the array into two sublists, that is sorted sublist and unsorted sublist. If you consider it as the list, you can make the group of sorted sublist and unsorted sublist. If you make it as an array, you can make it as sorted array and unsorted array, like that. So while designing the sorted and unsorted, first letter I will consider, that is first element I will consider it as sorted. First one will be considered as sorted because only one element is there, no? Anyhow it will be sorted. So after first element, whatever the values are there, these full values I will consider it as a unsorted sublist or a unsorted subarray. Now what I will do is compare with the sorted sublist. What I will do? Compare with the sorted sublist. So while comparing with the sorted sublist, if the value in the sorted sublist is greater than the value in unsorted sublist, I will make one right shift. The sorted elements will be there, no? I will make one right shift. So if I tell you don't get, let's solve the problem. You will get easily. Now what is the first? I said first will be sorted and all other will be unsorted. Now what is the element right here? 4. So 4 is in the unsorted sublist. So 5 is the sorted sublist element. Now I will compare these two. So what I will do, I will compare these two. While comparing, 5 will be here itself and this will be the free space. Free space because I am taking 4 in the temporary. Let's keep it in a temporary box. So 4 will be in the temporary box, 10 will be same, 1 will be same, 6 will be same and 2 will be same. So I will compare with the sorted sublist element. That is only one element is there. I will compare with 5. Therefore, 4 is less than 5. So, when 4 is less than 5, this sorted sublist element will be shifted one bit. This will be shifted one bit right side. Therefore, what will be the value? 5 will come here, 10, 1, 6, 2. Therefore, in sorted sublist there was only one, another element is not there. Therefore, only value left is 4. So, I will fill the 4 right here. Now thus my sorted sublist has came up to here 4 and 5. You can sort it in the increasing order or decreasing order. Most of the times examiner will ask to sort it in the increasing order, that is ascending order. So I am sorting it in increasing order. Now first element is what? 10. So I will compare it with the sorted sublist first element this side with 5. So what it will happen? 10 will go to the temporary block. What will be left right here? 4 will be left and 5 will be left. This will be the free space 1, 6, 2 because 10 I kept in the temporary. Now while comparing 10 with the 5, 5 is less than 10. So I will keep the element here only. Next I will compare with the 4. 4 is less than 10. So I will keep the value here only. So only the space, this space was left. So I wrote 10. So if you see 4, 5, 10. Increasing order, yeah. Next, what is the first element in the unsorted sublist? 1. Now I will keep 1 in the temporary block. So what it will be? 4, 5, 10. This will be the free space 6, 2. I will compare with the 10. So if I compare with 10, 1 is less than 10. 1 is less than 10. What I will do? I will shift one space right hand side the 10. Now 4, 5, 10 will be shifted one space. So 10 will be here, 6 and 2. This will be the free space. Now I will compare with the 5. So if I compare with 5, 1 is less than 5. What I will do? Shift the 5 to 1 bit right side. Therefore 4. This will be the free space. 5 will come here, 10, 6, 2. Now I will compare with the 4. So 1 is less than 4. What it will be? Here the free space will come. 4 will be shifted 1 bit right side. 4, 5, 10, 6, 2. Therefore only this space is left. There is no other element in the sorted sublist to be compared with 1. Therefore I will write 1 here. So my sorted sublist has came up to here. Now I will write here. Now what is the first element in the unsorted sublist? That is 6. I will keep 6 in the temporary. Therefore my sublist will be 1, 4, 5, 10. This will be the free space because 6 is kept in the temporary. Now I will compare with the 10. So up to here my sorted sublist was there, no? Now I will compare it with the 10. If I compare it with the 10, 6 is less than 10. What I will do? Shift 10 1 bit right hand side. So 1, 4, 5. So 10 is shifted 1 bit and this will be the free space. Now if I compare, 5 is less than 6. Okay, it is perfect in its place. 4 is less than 6. It is perfect in its place. 1 is less than 6. It is perfect in its place. So only this space is left. I will put 6. Now if you see sorted 1, 4, 5, 6, 10. It is in the increasing order. Only one element is left in the unsorted sublist. Now I will compare it. So to compare, I will put the 2 in the temporary block. Now 1, 4, 5, 6, 10 and this 2's place will be free space. Now if I compare 10 and 2, 2 is less than 10. So what 10 does? 10 will shift 1 right hand side. Therefore what will be my value? 1, 4, 5, 6, 10. So 10 is shifted 1 block here. This will be the free space. So this will be free space. 10 will shift here. Now I will compare 2 with 6. 2 is less than 6. Therefore 6 will come to this place. So 1, 4, 5, 6 will be shifted here. 6 and 10. Now I will compare 2 with 5. So 2 is less than 5. So 5 will be shifted. 1, 4, 5 will be shifted here. 6, 10. So here the free space is there. Now I will compare 2 with 4. So 2 is less than 4. Therefore 4 will be shifted. 1 free space, 4, 5, 6 and 10. Now I will compare with 1. Therefore 1 is less than 2. That is, it is perfect in its place. Now only one space is left and there is no element in the sorted sublist to be compared with with 2. Therefore I will place 2 here. So if you see, the elements are in increasing order 1, 2, 4, 5, 6, 10. So this is the insertion sort algorithm which we have assigned in the ascending order. If you liked the video, please subscribe for more engineering related topics, and if you have any doubt, please comment below. Thank you.